So let's put those together. I put together the pieces we figured out so far. We still have our expression grammar, we have interp below here, and I've got parse set up where it takes this s expression s. Here is the case we were just looking at, that multiplication case where we've set up some of the checking. Plus is going to be similar, of course, and for number in all caps, that's a special word that s expression match knows about, so that would check that s is just a number s expression. Set those up. I've also set up the test down here. So parse of the s expression 2 should be the expression that's just the number 2. Parse of the s expression plus 1, 2 should be converted to a plus expression, and so on. So we've got our test. We've got our setup, template-like setup of the program, and now we just need to finish it out. Let's look at this first case. If s is just a number s expression, that means that is a valid expression, and what we want to return is an exp. That is, we want to return a num-e to reflect the number s expression. Num-e wants a number, so I can't put just s there because s is an s expression, but I can convert this x expression to a number, and we know that sx arrow number will succeed in this case because s expression match has already checked that it's a number. Let's skip over plus because it's going to be like times. For times, we've already set up this matching, and we've already parsed this piece out, and we've parsed this piece out. Our goal is to create a multi that has those two parts in it. So that's what we can do here. Just use multi to put those two together. What if, oops, let's see. What if this first expression, or this first s expression, doesn't turn out to be a valid expression? Well, then parse won't return. In fact, if we don't match any of the three patterns, then we have an error case here that claims invalid input. If it does return, then it must have successfully determined that this is an expression and converted it to an exp that we can put together in multi. And then plus is going to be almost the same. The only difference with plus, since it has the same basic shape, is that we return a plus e instead of a multi. So with those three cases and those results, then our parser is complete. The advantage of writing this parser now is that we can write our interp test using parse instead of having to write out num-e and plus e and multi. So we see all of those parse tests there, plus the interp test, and all of our tests are succeeding. This also makes our language a little bit more real because we can use the plait read function to get an s expression from the user, and then we can parse the result of read using our parser, and then we can interpret to get the result. So if I run this, I get to write plus 1 times 8, 9. Let's make it even more complicated. Let's make this plus, say, plus 5, 6. Okay, so the read function knows how to take this text and treat it as an x expression, as if I wrote a back quote in front of it, but I get to write the curly program directly, and we get an 83 out, which is probably the right answer. Let's see, 72 plus 11, yes, 83. We're not going to use interp parse read very often because we will be more interested in writing test cases of this form, but you can see conceptually how we have implemented a real language here.